We're now moving into Chapter 6, which is exponents and polynomials. So today in section 6.1, we're going to talk about the exponent integers. So our objectives are evaluating and simplifying expressions that contain 0 and integer exponents. Integer exponents mean negative numbers. You'll remember what exponents are. We have a base, that's the x in this case, and that's the number that we will use as a factor. The exponent 4 tells us that we will use x as a factor 4 times. Now, up until now, you've seen positive exponents, and remember that to simplify x to the second power, in this case 3 to the second power, use 3 as a factor 2 times. So 3 to the second power, or 3 squared, equals 3 times 3, which equals 9. But what happens if we have an exponent that's 0 or is negative? Well, we're going to look at a table and see if we can come up with a pattern. Pause the video, go get a calculator so you'll be able to answer this question. 5 to the 5th power, you know, means 5 times 5 times 5 times 5 times 5. If I multiply that on the calculator, I get 3125. Likewise, 5 to the 4th power is 5 times 5 times 5 times 5. When you multiply those 4 factors of 5, you get 625. 5 to the 3rd power gives you 125. 5 to the 2nd power gives you 25. 5 to the 1st power gives you 5. Notice what's happening here. Each time that we go from 5 to the 1st to 5 to the 2nd, each time our exponent goes up by 1, we're multiplying by 5. But each time that we have our exponent going down 1, we're dividing by 5. 3125 divided by 5 is 625. And so on, and so on, and so on, and so on. Now we divide by 5. We end up with 5 as just our answer. But what happens if we have 5 to the 0 power, or 5 to the negative 1st power, or 5 to the negative 2nd power? We're going to continue this pattern. Each time the exponent decreases by 1, the value of the power is divided by 5. So let's take a look at 5 to the 0 power. You'll notice that 5 to the 0 power, we had 5 from 5 to the 1st. We're going to divide by 5 and we get 1. Now this is really important because any number going to the 0 power is going to give you 1. Any base to the 0 power gives you 1. Now if I divide 1 by 5, I get 1/5. 5 to the negative 1st power is the same thing as saying 1 over 5 to the 1st power, which is 5. Notice what happens. I have a negative exponent, and this negative exponent with this number that's in the numerator tells me to move the 5 to the denominator. It's going to be in the opposite location, and my exponent becomes positive. Likewise, 5 to the negative 2nd power is 1 over 5 divided by another 5, which is 1 over 25, which gives you 1 over 5 to the 2nd power. Again, this term that was in the numerator moves to the denominator, and the exponent becomes positive. This is in your book. This little chart is in your book and will tell you information about the zero power and negative integers. Let's take a look at this. 1 cup is 2 to the negative 4th gallons. I want to simplify that expression. Well, 2 to the negative 4th power is 1 over 2 to the 4th. Remember, this is in the numerator. Move the location, make the exponent positive. 2 to the 4th power means 2 times 2 times 2 times 2, which is 1 over 16. So 2 to the negative 4th gallons is equal to 1/16 of a gallon. A sandfly might have a wingspan up to 5 to the negative 3rd meters. I want to simplify this expression. Well, 5 to the negative 3rd. Again, move it to the opposite location and make the sign of the exponent positive. This means 5 times 5 times 5, which is 1 over 125. You try. Seven to the 0 power equals a negative 5 raised up to the negative 4th power equals, be very careful because the negative 5 is in parentheses. That's my base. And last, a negative 5 raised up to the negative 4th power. The base is the number directly before the exponent. In a negative 3 to the negative 4th power, the base in this one is negative because the negative sign is inside the parentheses. So that means I'm using a negative 3 times a negative 3 times a negative 3 times a negative 3. If it's outside the parentheses, these two things go together, and then the answer would be multiplied by a negative 1 at the very end. Now we're going to do some simplification that's bigger. If I have 7 times w to the negative 4th power, the important thing to remember is that this negative 4 only applies to the w. It has nothing to do with the 7. So make sure that you separate this and put the dot in between so that it's multiplication. Move the w down to the denominator and make the exponent positive. And now you're done. This one's a little bit trickier because the exponent is in the denominator, the negative exponent. This negative exponent has nothing at all to do with the negative 5, so that just stays as it is. So I'm going to do negative 5 times this fraction. I move the k up to the top and make my exponent positive. So my final answer is a negative 5k to the second. Now for something even trickier. Oh my goodness, we're putting a whole bunch of stuff together. Notice first that I have an a to the 0 power. That's just going to give me a 1. I have a b to the negative second power. That means I'm going to put 1 over b to the second. I have a c to the negative third. That means I'm going to put the c to the top and make the exponent positive, and this is over 1. And the last thing I have is d to the 6th, but it is in the denominator, and there it remains. If I put all of this together, I end up with 1 times 1 times 1 times c to the third is c to the third. Now I'm going to look at the denominator only. b to the second times 1 times d to the 6th gives me c to the third over b to the second times d to the 6th. Please complete the reading strategy sheet that is posted in our Google Classroom.